Hello and welcome. This is Dr. Kalman Andrassy, and today I'm going to be walking through all the different types of correlation strength tests, along with some of the effect size tests that are possible using SPSS today. All right. So I have gone ahead and I've downloaded once again my world.save database. And I'm going to be looking first for some interval and ratio level data to begin with. So let's go ahead and look here at percentage of the population that considers religion to be a very important part of their lives. And let's look at urban as well, which is the percentage of the population that lives in an urban area. So we can see if there's any relationship between the religiosity of a country based on how much of that country lives in an urban area. Okay, so the first test that I'm going to start with is Pearson's product moment correlation coefficient, R. But I'm also going to be hopefully moving on to doing Kendall's tau, as well as gamma, but also phi and Kramer's V. But pretty much all of these tests can be done in a very similar way. And just like with a hypothesis test, there's more than one way to run the analysis. But I'm going to be showing you the easy way and the way that's most relevant, especially if you're going to be doing something like Kendall's tau, where you have to know how many independent and dependent variable categories are available in the matrix that is created in the cross-tabulation so that you can determine which test to use. But you can also do this by going down to correlate, bivariate, and that would allow you to do Pearson's, Kendall's tau, Spearman's rho as well. All right, so anyway, let's get back to the way I was going to show it. Analyze descriptive statistics crosstabs, just as you did earlier with the hypothesis testing that we did. Analyze descriptive statistics crosstabs, and then we're going to take our independent variable, stick that in the column, so our percentage of the population that's urban is our independent variable. Religiosity, which is vi_rel, is going to be our dependent variable that we stick in the rows, and then we click the statistics tab. Okay, and as before with chi-square, you have that to be checked off. We have correlations, which is actually what we're going to be clicking for Pearson's R. But also you have nominal and ordinal, nominal by interval tests that you can check off as well. So you've got gamma, Summers D, Kendall's tau, B and C. You've got a bunch of nominal tests, including phi and Kramer's V, which we're going to be running later. Lambda is actually a proportional reduction in error effect size test, which we're also going to be running a little bit later. We've got eta, and if you square that value, you'd get eta squared. So that's another thing that is discussed in a lot of textbooks on statistical analyses. But for now, we're just going to click off correlations because, again, if we're doing interval and ratio level data, we can do a Pearson's R test, which is located under correlations. Okay, so we're going to hit continue, and then I'm going to hit OK. And we have our distribution of data. So all the different proportions of how important religion is, as well as percentage of the population that is urban. And we can go ahead and look at the symmetric measures. So if we were trying to determine significance, we'd look in this right column, and of course it is a statistically significant relationship. We'd reject our null hypothesis. We'd assert that there's probably something going on between the independent and dependent variables. Okay? But what's really important to look at here for correlation strength is this value under Pearson's R here. Pearson's R value is negative 0.520. What does that tell us? So first and foremost, the value itself, it can be plus or minus any number between 0 and 1. And the closer it is to 1, the greater the correlation strength is. Usually around 0.5, we consider that to be a pretty moderate. In some circumstances, we consider that to be a strong correlation. Okay? And the fact that it's negative means that the relationship is inverse. So if I were to plot these two variables on a scatter dot or a scatter plot distribution graph, vi_rel on the, let's put that on the y-axis, urban on the x-axis, and we hit OK, we'd see that the general trend of the dots appears to be going down. And this is going to be important for when you do regression analysis. If we put a line of best fit, as we can see, that general trend of the dots is indeed going downward. And that's what that negative means, that it's an inverse relationship. Otherwise, it'd be going up. Let me see if there's anything I can think of that goes up. How about, let's find a graph here that might be relevant. How about Gini index? Let's use that as our independent variable and see if that affects the level of economic development in a country, perhaps. I don't actually know if that's a good variable. Let's look at AIDS cases. I mean, there's probably a relationship there. It'd probably be inverse, though, so never mind about that. How about unions and if that affects the population of a country? Yeah, maybe we can expect to see. Where'd it go? I lost it. Population 2020. I kind of expect that to be related. Okay, it doesn't actually look like it is, but hey. Let's pretend I didn't run this analysis, but as you can see, it's kind of generally going upward. It's too flat. It's definitely a random relationship. But, if this line were, can I move this line? I can't move this line. If this line were more of a 45-degree angle or approaching a 45-degree angle, that's when we determine that it's a positive correlation. Sorry for wasting your time there, in other words. All right, so that's basically it. So back here, we go back to this Pearson's R value, negative 0.520. We'd probably call that a moderate relationship. And in order to determine effect size, the coefficient of determination, all we'd have to do is take that number and multiply it by itself. So we take negative 0.52. Where's the negative button? Anyway, I don't see the negative button. But you know that a negative times a negative equals a positive. 0.52 negative. So it would become positive either way. And we'd get a r-squared value, and r-squared value of 0.2704. And basically what that means is that 27.04% of the variability in the dependent variable is based on or contingent upon variation in the independent variable. So basically, if the independent variable changes, 27.04% of the dependent variable tends to change in kind. And this is going to be very useful for us when we try to make predictions using regression analysis. Okay, so that's how you run a Pearson's R. But of course, you're not always going to be interested in Pearson's R. Let's see, we've got a nice ordinal scale of 1 to 7 from fewest rights to the most rights. So we're going to look at political rights. And we'll compare that to whether or not a country is very democratic or most democratic to least democratic. Or let's go the opposite way. I assume that the more democratic a country is, the more rights it's probably going to have. So what we're going to do is we're going to go ahead and run a Kendall's Tau test for that. Because, of course, ordinal by ordinal level data. All right, so we have political rights, which is what we are trying to determine is affected by percentage of the population that is democratic, which is the Freedom House rating, FH03. Okay, we're going to click on statistics. I'm going to run the correlation just so we can get Spearman's rho. I'm also going to run Kendall's Tau B and C, depending on the way that the matrix looks for our data. Actually, I think it's going to be Kendall's Tau B in this particular case, because if I remember correctly, there are 7 categories for political rights and 7 categories for the Freedom House score. So it's going to be a 7 by 7 square. So we should be running Kendall's Tau C, but of course, let's double check by running both the analyses. And hit continue. I'm going to hit OK. And again, my camera is right in the way of where I should be clicking. So here we go. We have our political rights score by our democratic rating. So we got fewest rights, 2, 3, 4, 5, 6. Most rights, least democratic, most democratic. But it looks like it might not be, because it looks like we have 8 categories here as our potential choice. Because here it's fewest rights is 1 and most rights would be 7. Here it's 1 and most democratic would be 8. So I was wrong. We're going to be running a Kendall's tau C. So again, we look at our correlation. There's our Spearman correlation. 0.000 is our significance, so it's definitely a statistically significant relationship. And now we determine, is it square-shaped or is it rectangular? And it is more rectangular than square-shaped by one category in the Freedom House Index. So we're going to look at Kendall's tau C instead of Kendall's tau B. So if it were a 3 by 3 square, or a 4 by 4, or 5 by 5, or 6 by 6, we'd look at Kendall's tau B. But here it's 7 by 8. So it's not a perfect square. Anyway, our Kendall's tau C value is 0.653. So that is, of course, a fairly strong correlation. You'd definitely be considering it at least moderate and probably leaning towards a strong correlation once we get to that point. Okay? So that is what would be considered a strong correlation. Now, there isn't a particular effect size test that we'd run using ordinal by ordinal data, except for lambda, okay? And that's going to be also what we use for nominal level data, so we're going to save that for the next analysis that I run. But basically, yeah, you're gonna report this Kendall's tau C. You're gonna say that that's probably a moderate to strong correlation. All right, next up, let's try to find some nominal data. We've got the region of the world and religious culture. So, clearly, different parts of the world probably have more different religious influences. You got the West, that's mostly Christian. The East is probably going to be a mix of different religions, including Buddhism, maybe Shintoism, and to some extent maybe even Hinduism. Maybe African areas will be a mix of Christian and Muslim. Of course, the Middle East and Northern Africa is going to be primarily Muslim. You got a lot of the island nations, mostly Muslim. In Oceania, rather, I don't think that's actually accurate. I'm not saying Oceania, but Indonesia and those countries, there's a lot of Islamic culture there. I actually want to look up where Oceania actually lies. I know that Australia and New Zealand would be part of that. I wonder if Micronesia is, or Polynesia. That's probably Oceania. Probably not Indonesia in Oceania, though. It's probably considered Southeast Asia. But I'm digressing here. So we're going to see if religious culture is affected by the type of society. So again, analyze descriptive statistics crosstabs. This time we're looking at how the region we're in affects religious, is it category or no, type rel, right? Yeah, type rel. So region by type of religion. Now we're going to hit statistics again. We're not going to be running these analyses anymore. Instead, since we have nominal level data, we're going to do a chi-square test. We're going to click off phi and Kramer's V. But also I'm going to include lambda because that's going to be our proportional reduction in error test that we're going to run along with nominal data. And just as easily I could have done this with ordinal by ordinal data. So feel free to go back and run a lambda analysis if you want for the previous variables that we looked at. But once I have all those things checked off, I'm going to hit OK, and then OK here. And again, we see our distribution. So we have all our religious categories: Roman Catholic, Protestant, Orthodox, Jewish, Muslim, Hindu, Eastern, and other. Of course, those are all purely nominal categorical data. There's no order to this or anything. Can't add Protestant plus Orthodox, divide by 2, and get Jewish. Doesn't make sense. And then, of course, you have all the regions, which are also purely names, categorical. You can't take Sub-Saharan Africa plus South Asia plus East Asia, divide by 3, and get Southeast Asia. Doesn't make sense. So we look first at our chi-square test. There is indeed a statistically significant relationship. So depending on what part of the world you're in, your religious culture is probably going to be different. Okay? And then we look at our symmetric measures to determine our effect size. So first and foremost, we have to determine if we're going to be running phi or if we're going to be running Kramer's V. So phi is for dichotomous variables like yes or no, or Republican versus Democrat, or male versus female. It doesn't work for anything that involves more categories. So in this case, we have how many categories? 1, 2, 3, 4, 5, 6, 7, 8 religion categories, and 3, 6, 9, 10 different categories for religiosity, it seems. So we're definitely going to go with Kramer's V, which is 0.542, which again, probably at least a moderate level of a pull of the independent variable on the dependent variable. And then we go up and we take a look at our lambda score. So if we look at our lambda value, it's 0.361, okay? And what that basically means is that just like with a Pearson's R squared coefficient of determination, basically 36.1% of the variation in the dependent variable is contingent upon the variation in the independent variable. So if your region changes, there's basically a 36.1% chance that your religion is also going to be changing along with it. So basically, if you know just a person's region of the world, you're going to be about 36% more likely to guess what the dominant religious culture is in that society. Okay, that's basically what proportional reduction in error is ultimately all about. And that pretty much sums it up. If you can run those few tests, you can do pretty much anything you need to determine correlation strength in most social science data analysis classes that you might take.